Okay, so in this example, we want to find the value of c so that this piecewise function is continuous. We know that each of these pieces on its own over the real numbers is continuous. X squared minus 4, that's a quadratic, that's continuous. And 2x minus 5 is a line, that's continuous. But when we take pieces of that, each of these functions, and we rejoin the pieces to make a new function, in order for that piecewise function to be continuous, the pieces need to line up and meet, and the value of the function needs to exist at that point. So we want to find the value of c so that happens, so that these two pieces line up, they join, and that value exists. So there's no breaks or holes in the graph. Now, looking at this graphically, the red is the x squared minus 4. And the blue function is the linear function 2x minus 5 when we graph it. And we can see at this point right here is where they line up. So if we were to let c be 1, assuming that this is where they actually meet, we don't know for sure yet because it could be like 1.1 or 1.05. It could be something this close to 1. So we're going to algebraically check and verify that that's the point that we're looking at. But if we were to take and assume that 1 was our value of c, that would mean that we would take the quadratic for all the values less than or equal to 1. So we would use for our piecewise function this piece that I'm highlighting here, this piece for the quadratic, and then for the linear function, we would use the piece of the linear function that's greater than 1. So we would use this piece. So if these two functions meet up at 1, then this would be a continuous function when we join these two pieces together. So what we're going to do is we're going to verify that they actually meet up at 1 algebraically by setting these equal to each other. So we want to find the value of x where these two functions intersect. So this is going to give us a quadratic to solve. I'm going to subtract 2x from both sides. I'm going to add 5 to both sides, so that's going to give me a plus 1, and then that's going to give me a 0 on the right-hand side. Now, once we have this quadratic to solve, we can solve it by factoring, complete the square, quadratic formula, however you want to try to solve this. I'm going to use factoring because I can see that this factors nicely. So I have x minus 1, x minus 1. So I can see the solution to this quadratic equation is x equals 1 with the multiplicity of 2. So we just verified that these two functions actually do intersect at 1, and it's not something like 1.05 or something really close to 1. We verified that it was 1 exactly, so our c would have to be 1. So the highlighted function that I have in green here would be if we graphed the piecewise function x squared minus 4 where x is less than or equal to 1. So now we're going to let c be 1. And if I graph the second piece, 2x minus 5, where x is greater than 1, that would be this highlighted green function. And because we know that they meet up, the value of that function exists, we know that that value of c would need to be 1 in order to make this piecewise function continuous.